Hello, and welcome to another new episode of Building SaaS on AWS, the AWS SaaS Factory show for builders of SaaS here on Twitch. My name is Anthony McClure, and I am a solutions architect with the AWS SaaS Factory and your host for today's show. If you are currently a builder of software as a service solutions, or are even just getting started and learning how to design, build, deploy, and operate applications inside of multi-tenant architectures, then this is the show for you. In every episode, we strive to bring forth subject matter experts, friends, and partners to discuss those deep dive topics in the varied areas of software as a service. And as always, this, of course, is no different today. First, before we dive into our topic, though, I want to give a very big shout out and a welcome to everybody that is joining us here live on Twitch this morning. If you are here with us, please jump into the chat and give a comment. Let us know where you're from. And while you're there, be sure to say hello to our good friend, Mr. Bill Tarr, who is acting as our moderator for today. And if you have any questions for myself or our guest as we are discussing our topic, please feel free to put those questions into the chat as well. And I will do my best to get those questions brought up and answered for you as far as we have time to do so. So with all of that out of the way, let's go ahead and jump into today's topic. Now, we've discussed generative AI and software as a service together multiple times here in the past. But today, we want to take a little bit of a different look at generative AI and SaaS, and specifically around some of the concerns that have been raised regarding data privacy. Specifically, when we're talking about the large language models, those foundation models that exist inside or underneath these generative AI solutions, how can we train and fine tune these LLMs using your company's or organization's data or your customers' data while still making sure that we are protecting that data and making sure that privacy is being respected? Or with the many and proliferating sets of legislation such as GDPR that is making its way now worldwide, how can we leverage LLMs while still complying with these regulations and respecting the right to be forgotten? So, to help us address these questions as well as some others, and perhaps show a solution to the problem, I would first like to recommend or bring to the show our first guest for today, and that is Mr. Sean Falconer, who comes to us from great partner Skyflow. Sean, welcome to the show.
Hey, Anthony. Thank you for having me. I'm excited to be here.
Awesome, excellent. Yes. Why don't you go ahead and tell us a little bit about yourself, Sean, as well as Skyflow, and what you do?
Yeah, absolutely. So I run developer relations and marketing at Skyflow. I have a long history as a software engineer, and then have through a variety of different circumstances ended up in sort of a more outward-facing sort of engineering role in my career, which has been a real joy to be part of because I get to do this kind of stuff and represent the company, and also connect with a lot of solutions architects, engineers,
Mhm.
CTOs, and stuff like that outside of the company that I particularly work for, and learn a lot about like what their challenges are, especially in the data privacy, data security space, which is where Skyflow is focused. And Skyflow has been a company now for about 5 years. We spent about
Mhm.
2 years in our R&D, really developing the product. It's kind of hard to take a move fast, break things approach to building a data privacy platform. So you need to do things with care because mistakes are very, very costly when it comes to this kind of stuff. But essentially, we are a data privacy vault and available as a service. And that gives you a way as a business to essentially isolate, protect, and govern access to your most precious sort of customer data, what you deem sensitive, your PII. In healthcare, it could be PHI, credit card information, all this type of stuff, and give you a way to essentially keep it secure while keeping it also usable. And we've been able to take that technology and now over the last year and a half with all the growth in generative AI, also apply it to use cases around generative AI, which is, some of the stuff that we'll be talking about today. And we've seen tremendous growth over the last year in interest in what we're doing in that space as well, because of all these types of challenges that you talked about during the introduction.
Well, that sounds fantastic, Sean. I'm looking forward to hearing more about Skyflow and the tool that you're bringing to us as far as a solution, and maybe getting to see a little bit of it a little bit later on in the show. Yeah.
Yeah, absolutely.
All right, great. Well, to also help us today, we have a couple of other additional guests. I know some of which are both which have worked with you, Sean, and are no strangers to the show. Let's put it that way. I would like to go ahead and introduce our other two guests today. We have Farouk Ashraf, who is with us, as well as Ravi Yadav. Welcome, both of you, once again to the show, as you're both veterans.
Thanks, Anthony.
Thanks for having us.
Yes, absolutely. Farouk, why don't you go ahead and introduce yourself, and then we'll have Ravi come second.
So I am a solutions architect at AWS. I work with the ISV customers, sort of the segment within AWS, and I specialize in SaaS architectures and lately in Gen AI architectures as well. So that's where sort of marrying the two sides of technology.
Okay, thank you, Farouk. Ravi.
Yeah, I'm Ravi Yadav. I lead our containers and serverless go-to-market for our ISV customers. I've had the opportunity to work with Sean and everybody on the screen here, right? As we help our customers and partners build SaaS on AWS, there's obviously alignment in terms of how we partner together and then help there.
Excellent. Well, thank you to everyone for being with us here today. And Farouk, wanted to take a quick second here to talk about the last time that you and Ravi were with us, which was back in November of last year here on the show. And in that episode, we talked about kind of the precursor to where we're getting to today, right? As you and Ravi kind of came together and produced this blog post for us here that I'm showing on the screen. That discusses how to build these kind of multi-tenant, so really SaaS-based chatbots using retrieval augmented generation and Amazon Bedrock, along with EKS. You want to give us a quick rundown of that, Farouk, and what you guys did there, and then maybe how you jumped from there to ultimately kind of getting into this data privacy area?
Yeah, absolutely. So as last year the Gen AI wave was taking shape, we were thinking internally on how can we build a reference architecture for our enterprise customers who operate at large scale, to build an architecture pattern that would be scalable for them as well as cost efficient. And also it will be based on an infrastructure that is in broad adoption across various enterprises and ISV customers. So we did a bit of study, and we understood that containers was a common pattern that a lot of our ISV customers and enterprise customers were adopting, and there was a significant growth on that sort of architecture in general. So we took Amazon EKS as the underlying infrastructure that provides our containerization mechanism and the orchestration mechanism for that. And at the same time, we were developing products for Gen AI, particularly Amazon Bedrock was taking shape, and a lot of some of the popular models were being added to Bedrock, and it's a managed service, API based. So we thought of bringing together all these different components and presenting a RAG based architecture that would be a very common pattern at that time, and even today as we go forward. RAG is the most common pattern that is being adopted by enterprises to build Gen AI applications. So that's where we came up with this idea, and then the result was this blog post, and there's a code repo that is associated with the blog post that our guests can visit and see. So Ravi, if you want to add something to that, that would be great.
Yeah, absolutely. One thing I'll add is, as a background to all of this, right? One of the things we've seen is with the advent of generative AI, machine learning, going through an inflection point, there's few things that have been happening, right? So there's compute capacity in itself that has been increasing. Like the data sizes of the data sets that we deal with are growing, and the models themselves are becoming more and more sophisticated, right? So that all has led to customers and partners looking into building different kind of unique use cases leveraging generative AI. Now, in this particular context, as a backdrop of the architecture that we're currently looking at, we chose EKS. Primarily because once customers have made a choice of using containers, and based on the advantages it provides, EKS is a natural way or best way to run Kubernetes, to be able to manage the control plane that we provide from an AWS perspective, and a lot of the heavy lifting that comes associated with that. Customers don't necessarily need to be able to manage that, right? So that's where EKS fits into this entire picture, right? And there's several advantages it provides, like automated scaling, increased resiliency, workload isolation, maximizing your GPU resources, and in itself being cost-effective solution as well.
Yeah, and I'll just add that when I saw this article come out, I had immediately reached out to Farouk and Ravi because one, we're AWS partners, but this was also a pattern that we were seeing with the customers that we were talking to, and additionally, we were building our own sort of privacy safe content copilot that I'll show some demos of later. That is built on EKS and built on Bedrock and these types of technologies. So it made a lot of sense to kind of bring the best of the work that we were doing together to do to see how we could sort of help promote this approach to building on Gen AI to a larger audience.
Yeah, excellent. Well, I know all of that work really, certainly struck a chord, I think, with our audience, and obviously, Sean, it did for you as well, as far as looking to work together to try and bring these data privacy concerns that you've been working with, along with this RAG and LLM and generative AI technology that's so catched fire right across the internet at this point, or across the business, I should say. With that, though, maybe this is a good time to go ahead and dive a little bit deeper into the topic at hand then. So when we're talking about generative AI and we're talking about working with large language models, what are some of these challenges you're seeing regarding privacy that are consistently coming up?
Yeah, I think that the big challenge that all businesses are facing that want to leverage, all this customer data or their internal documents, like this is really truly the first time in sort of the history of technology that there's something that can help us sort of unlock this massive amount of unstructured data that every business is sitting on. But at the same time, there's a lot of concerns about what it means to essentially share some of that stuff with the model, because the big challenge around something like an AI model, in particular like large language models, which is mostly what we're going to be talking about, is that there's no row column to go and delete that information if you need to delete it. There's no way to sort of undo that thing. It's like me asking you to delete the part of your brain that knows what an apple is. Like that's, other than some drastic head trauma, like you're not going to lose that information essentially, because LLMs are just fundamentally different technology. Like privacy is already hard in the world of databases and where we can actually go and sort of individually pinpoint the data of a customer. But in an LLM, it's really like you're dealing once things are in the LLM and you have the model, it's like a soupy broth. And I can't tell the difference between the blended carrots and the blended celery at that point. So now how can I pinpoint the data? And in the world of GDPR, the right to be forgotten, a growing sort of plethora of privacy regulations around the world, I can't necessarily comply with those things, even things like data residency requirements. I can't shard the model into different regions in the world based on where my customers are in any kind of reasonable way. So that becomes a really big challenge for companies, and people have tried to, through fine tuning the models, put certain guardrails in place to try to protect against it. But it's very, very hard once it's actually in the model to do that, because they're just not designed for that level of protection. But you can kind of change the nature of the problem by shifting some of that stuff left to looking at how you're training the models, where we understand sort of more traditional technology of rows and columns and actually being able to pinpoint the data before it ends up in the brothy soup of the LLM.
So catching it at a time where you have basically more understanding of the data model itself versus this kind of unstructured thing that becomes the LLM after the fact.
Yeah, exactly.
So when we were speaking first when I first brought you on, and we were talking about Skyflow and what you do there. You had mentioned something that piqued my interest. I think you called it a data vault or privacy vault, right? What exactly is that, Sean, from your perspective, and how does that help to address some of these concerns that you're raising here?
Yeah, I mean, our position as a company is essentially that in the same way that over the last decade, we've recognized that there's different sort of classes of sensitive data. So you have things like encryption keys, secrets, passwords, and we've defined specialized technology for handling those things. So we have KMSs for encryption keys, we have secrets managers for secrets, we have identity providers for passwords. But that wasn't always the case. Like we used to put passwords in a database 20 years ago. They used to be in plain text in a database, and secrets. I mean, still this is the case some of the times, but secrets exist in source codes or maybe in an environment file. But these are like, essentially the keys to the kingdom. They unlock a lot of stuff, and they're also the source of a lot of times like cyber attacks. But we've recognized that those are different classes of data. They're fundamentally different than sort of non-sensitive application data, and the rules of engagement are different. Like you need to rotate encryption keys, you need to rotate secrets. So there's different rules. And we believe as a company that PII or sensitive customer data is also a fundamentally different type of data. And when you start to think about it that way, that means that you require a different type of technology for essentially keeping that data secure while also usable. Because the rules of engagement for PII are also very different than the rules of engagement for essentially non-sensitive application data that you might put in a transactional database, or even the type of data that you might aggregate down into like a warehouse for analytics use cases or data science. And essentially, our position is that that type of technology is what we call a data privacy vault. And this was something that has been pioneered by other companies. A lot of sort of leading large technology companies like your Google, Netflix, Shopify, Apples of the world have developed similar type of technology internally. And then even about a year and a half ago, the IEEE came out with an article that talked about the future of privacy engineering. And in that article, it talks about how just like everybody should have in any modern cloud infrastructure, an API gateway, database, warehouse, these kind of backend services. If you're handling customer data, their recommendation from the IEEE is that you need to be using this data privacy vault architectural pattern for doing that. So we've essentially taken some of the inspiration from those companies and then built that for everyone else and made it available as a service. And I would say, because this is the only thing that we do and the only thing that we care about, it's also better than probably what they've built internally, because we're trying to do that holistically for any type of use case. And a big part of our sort of secret sauce is something that we developed and own the patent on, which is what we call polymorphic encryption and tokenization, which allows you to essentially not only keep data encrypted during rest or encrypted during transit, but also during operations on the data. And we can also produce what we call polymorphic tokens that allow you to create de-identified non-sensitive data that you can store in your database, your LLM, your warehouse, that still allows you to actually perform essentially the utility that you want out of that data without leaking PII to internal or external people.
Wow, that was fascinating. Go ahead.
Sean, one thing I wanted to touch on as well, when we're dealing with things like large language models, right? One of the things is essential is that you want to be able to eliminate different kinds of sensitive information from the prompt context themselves, right? To be able to guarantee that it never appears in a model's response. How can a data privacy vault, or how do you think about how a data privacy vault prevents sensitive data from entering different kind of AI models during different stages, like during training, fine tuning, or inference?
Yeah, absolutely. So essentially, if we think about it through training, then the vault acts like what we call a privacy gateway. So we're typically, when you're doing training, whether that is you're fine tuning, you're building a RAG model, you're even building a foundation model from scratch, you have a bunch of source material that you're starting out with. And that source material could have sensitive data within it. And essentially, the privacy gateway sits at the head of that training pipeline. And you can take all those unstructured data and essentially pass it through the Skyflow gateway, where the vault or the gateway will automatically detect where sensitive data is within those documents, and then essentially replace it with what we call context-aware tokens. So something like my name, Sean Faulkner, would replace with like name as a tag to indicate the entity is the name. And then maybe it's a UUID or something like that. And we can do that consistently so that every time Sean Faulkner is encountered, it's generating essentially the same sort of context-aware token. Because ultimately the LLM doesn't care that my name is there. It just needs representation and understand that it's a name. And then from there, you're basically spitting out clean data where your RAG pipeline or your fine-tuning pipeline or whatever it is continues as normal using whatever tooling that you want to use, allowing you to use private models, public models, whatever sort of combination of models and tooling that you want. And then on inference, a similar process. So I put in a prompt like, where is Sean Faulkner born? Then I'm going to pass that through the LLM gateway and essentially replace Sean Faulkner with that de-identified value, and then pass that on to perform inference with the model. And also, if we're doing something like RAG, we're going to create embeddings based on the clean version of the prompt, hit the vector database, bring back the chunks, and match that way. And then if the response has de-identified values within it, then also basically on the egress, before we show to the user, we're going to pass those tokens back through the Skyflow gateway to re-identify the values, but based on the policies that you create within the vault. So this allows you to essentially control who sees what, when, and where, so that depending on who's asking, they should get different responses. So if Anthony is in customer support and Farouk is the CEO of the company, we don't want Anthony to be able to say, hey, what is the salary of the CEO of the company, unless that's public information, or find out like who's up for termination at the end of the quarter. Those are the types of prompts that we want him, some random person within the company to probably not have access to. So we really need to be able to control at a fine-grained level how that information gets exposed. And I think that's one of the big challenges when I look at sort of what's happening in the industry, is a lot of times there's a sense that if we kind of build we run a private model, we build sort of a walled kingdom around our model, then we're secure. But that's a lot like sort of perimeter security that we used to do, with on-prem systems. Like, how do you trust the people that are inside the fence are doing the right thing? That is key. And we have to be thinking sort of a second level beyond just protecting essentially access at the highest level, but how do we control when you're talking to the soup, who gets the peas and who gets the carrots, essentially.
That makes a lot of sense. And one quick follow-up on that, right? Beyond just PII, what other kind of sensitive data should users be thinking about?
Yeah, that's a great question. So with our product, you can actually add in, we basically have like allow and deny lists where you can add in, you can customize, because there might be things that as a company are sensitive to you that are not necessarily sensitive to other companies. Like, let's say that you have a new product that's going to be launching and it's called, like Titan or something. Then that word might be sensitive within your company and you want to protect it. You don't necessarily want to share it with the model. Then you can essentially have something where you adjust how our APIs work to be able to pick up those and also de-identify them. There's also certain circumstances where you might want to allow certain sensitive data depending on what it is that you're trying to do. I mean, when we're talking about training models, there's always some like a lot of testing and iteration and nuance that's going to be applied. You can't just necessarily like apply the same exact formula for every single use case. And it might take a certain amount of adjusting and testing. So there might be certain times where you're okay allowing a certain amount of potential PII leakage or sensitive data into the model in order to preserve the integrity of the model. And that's also something that's adjustable. But we have some like interesting use cases. We're working with a company in the United States that's building like essentially like LLM-powered digital nurses. They're training on a lot of sensitive data from hospitals and doctors, audio files, doctors' notes, so stuff like that. And there's certain things that they need to be able to do that's really specific to their use case. Like they need to preserve the delta between doctors' visits, but they don't want to preserve the exact date, because then you might be able to pinpoint who the patient was. So I want to know that it took place 9 days apart, but I don't want to know that it was, February 2nd of this year was the first visit, for example. So we need to be able to generate essentially those sort of context-aware tokens that still preserve the integrity, certain properties of the original data.
Very fascinating. Farouk, did you have a question as well?
Yeah, Sean. So diving a little bit deeper into the technical part of it. So I was just thinking, like in the background of RAG architecture, right? Typically, there are frameworks that organizations would use, like for orchestrating their prompts and responses and so on, something like Llama Index or LangChain, or the emerging pattern of agents. So how does this the operation with Vault and the redaction of PII data and the reverse operation take place in that kind of orchestration chain?
Yeah, I mean, I would say like the product itself is technology agnostic. Like just like you have a lot of flexibility over what model you're using, you also have flexibility over what you're using for orchestration, LangChain or whatever sort of open combination of open source or proprietary tooling that you want to use. And essentially, it's in Skyflow, whether you're integrating us for sort of some of the core customer use cases around credit card handling and PII and data residency, or you're using us as an LLM privacy gateway. It's all an API-based integration that you're in control of, and you can essentially plug that in wherever it makes sense. I would say when it comes to training, ideally you're doing that as close to the data source as possible, because when it comes to handling sensitive data, just like when we talk about encryption, like we want to be able to do that as early in the life cycle of the data as possible, so that we're minimizing essentially the potential exposure risk. You want to reduce the footprint and the amount of places that are essentially touching that data. So you want to do as close to source as possible. And then when it comes to re-identification, you want to re-identify as late as possible, because that way the sort of chain of command that's going through like the inference process is also not handling sort of the raw combustible material of the PII.
Got it. Yeah. Thanks.
I also heard in what you were talking about earlier, Sean, about data and this customer experience that you were describing here with the healthcare industry, and you'd mentioned that there was many different kinds of data sources that that ultimately this customer was trying to work with. So what are the common or types of data that Skyflow can work with?
Mm-hmm. Yeah, so we work with both, like, when we're talking about LLMs, we work with both text. So you can put in, whatever freeform text that you want and hit an endpoint to automatically detect and replace PII there. Or you can also do this with certain types of files. So like documents, PDFs, audio files is very common. There's a lot of use cases around audio files. We're looking at additional things around like even video. It's not something we support currently. And also there's a lot of use cases that people are interested in with even pictures and stuff like that, where you might want to be able to train a model using inputs from, let's say, I don't know, security cameras or something like that. And you might want to be able to detect and redact people's faces in some capacity from like a privacy perspective. So there's a lot of interesting use cases at the moment, primarily focused on, I would say, text heavy files or audio files, where we can do a combination of things of both translating into the text and or even looking at the audio files directly. And then we can do this across multiple languages as well.
Fantastic. Well, I know our audience is probably chomping at the bit just a little bit to see, what this actually looks like from a real perspective. And I know, Sean, you have some demos prepared for us today. Before we dive into that, though, I do want to welcome everybody that has joined us today here live on Twitch. If you have joined us late, you are watching Building SaaS on AWS. And I am joined today by Ravi Yadav and Farouk Shef from within AWS, and Mr. Sean Falconer, who's the head of developer relations at Skyflow. And we are discussing data privacy concerns and how to address that when working with generative AI models. So, Sean, yeah, want to maybe give us a bit of a demo here?
Yeah, let's do that. I'll skip. We already kind of talked about some of the stuff, but I'll skip sort of into. I have a couple different demos to show. This first one is a pretty simple demo that we created to show how some of the replacement of PII works. So the scenario here is it's essentially a medical health customer support. So I'm a customer support agent. Internally, I have essentially like a co-pilot where I can ask certain types of questions about the patient. and in order to provide better assistance. And here, it's obviously there's a lot of sensitive data in terms of who these individuals are, who the patients are, and we want to be able to control access to a customer support agent probably in a different way than we want to control access to like the doctor. And that kind of goes back to this issue we're talking about of around how do you control sort of who sees what, when, and where. So I'll jump over to the demo just to kind of get into this, but I have a bunch of patient reference information here, sort of chat history, and over here I can ask things like who is the patient, and I can say what's the policy number. And then, so everything that's kind of in this like bluish, purplish color is essentially what we deem sensitive. So I can click this, and this is essentially what the model's actually seeing. So the model is seeing, a UUID representation of the policy number or the group number or the name or the date of birth. And we can produce these in different sort of formats. So when we're doing essentially creating the RAG model, what we're building embeddings off of is this kind of representation of the data. And then same thing when we're doing inference, we're basically cleaning those prompts and then sending the clean prompts on, and then automatically re-identifying those values based on the policies that are in place. So this is pretty simple stuff here, just to kind of get you a sense for what we're talking about. And then I'll jump back to get into a little bit more detail about a sort of more complex use case that is more aligned with some of the stuff that we've from Farouk and Ravi's original blog post that they wrote, which is what we built internally. We built a product called Verba GPT, which is a content copilot. And the idea here was that we wanted to be able to take advantage of all the value that we're seeing in the industry from using large language models to speed up our ability to create certain types of content. So that could be documentation, blog posts, press releases, all this type of stuff. And now we could use something like ChatGPT for some of this stuff, but ChatGPT is a general tool. So it's not going to know all the things that we know about Skyflow. So could you use it as a starting point? Perhaps, but you're going to get kind of general responses. It's not going to be sort of have our tone and the formats that we need in order to craft this stuff. So we built this product to be able to produce content that's a lot closer to essentially a finalized product than you might get from a general tool. At the same time, we also wanted to take advantage of using Skyflow technology to do privacy safe training, privacy safe inference, have fine grained access control. As an example, we're using things like PRDs, upcoming product features to train these to build our RAG model as well. And while it's important for the docs team to have access to that information so that they can write documentation about new features, we don't necessarily want the sales team to have access to all the information because we don't want them to be confused about what product features exist and what don't. And then they end up selling something that we don't actually have launched yet. So we want to be able to have some control over that. And before I get into the demo, I wanted to give a little bit. I have some slides built out to kind of show some of the stuff that we've been talking about by using our hands and stuff to kind of show how this works. But essentially what we're doing is we're taking our training sources. So we have things like docs, blogs, white papers, PRDs, contracts. This could be, this is what we're doing, but this could be, wherever your sources are as well. And essentially this could be something like a contract. So I'm at Snowflake's big event in San Francisco this week. This is a partner agreement form that we filled out in order to participate in that event. And while it's helpful for Verba GPT to know that we're going to be at the Snowflake event so that we can create a social media post that's relevant or something like that, it doesn't need to necessarily have access to like our business ID, my phone number, and these types of things. So what we can do is essentially detect that data, keep the context of name, phone, email, business ID, and so forth, but replace the actual sensitive data with a de-identified value. And then now we have clean data on the other side here where we can use this for our chunking. So we can use, a combination in this case of Python and LangChain to create our chunking, build our embedding model. So we're building our embeddings based off of the clean data, and then we can store that down in our vector database that we're going to use as part of the information retrieval step of our RAG system. And
Sean, quick question on that
yeah,
one
go
on
ahead.
the previous workflow. The first part of this workflow, right? How
Mhm.
does Skyflow detect and replace PII, right? How does it
Yeah,
know
how does it
a
even
name is
know,
a name,
right?
an email is an email?
Yeah, absolutely. So we use a combination of uh, a bunch of machine learning techniques and NLP techniques. So we're using a combination of models, some stuff that we built internally to be able to detect these types of things, because it's a lot more nuanced, of course, than just doing a regex match against an email or a social security number or something like that. So we train models on this, and for our customers that are interested in this, we can show sort of side by side comparison of how we stack up against other similar approaches to detecting things like BII. But this is something that we like. Again, like this is what we specialize in. So we're really, really focused on finding sort of the most sensitive critical data than necessarily just a sort of general tool to be able to pull out entities.
Got it. Okay. Have
Yeah.
you ever seen any example scenarios, use cases where it makes sense or where you want any kind of sensitive data to go through the model?
Yeah. So I was talking a little bit about this earlier, where there can be situations where you need to preserve either certain data integrity, like the use case I was talking about earlier of the delta between patient visits. So that is really sort of like a case by case basis of what do you need, what does the model need in order to get the performance that you need for your specific use case. So it is an iterative process. It's not necessarily just, hey, like I threw Skyflow in and now I'm off to the races and everything's going to be perfect.
Mhm.
Anything that we're doing when we're talking about AI is always going to be a little bit more complicated and nuanced than the proof of concept demoware version of that in order to do this in production. So it does take testing and iteration in order to see create something that's going to work for you. And there can be certain circumstances, I think, where it is important to share some level of sensitive data with the model in order to get the performance that you want. But ideally, you want to reduce that footprint as much as possible, and it comes down to like how comfortable you are. I would say this similar to when we're building any kind of application. There's going to be certain circumstances where there's something that we need to do with the data where we have to make choices of the absolutely most secure thing that we can do versus reducing some of the constraints around the security in order to facilitate the use case. Does that make sense?
Thanks.
Yeah.
Yeah, Sean, just a
So,
quick follow-up also on that. So talking of the vector databases, so I'm just thinking of like when you're actually building your vector database, like initially,
mhm.
there's a lot of ingestion of data. So this tells me that Vault can actually be used at that time also to kind of filter that data through Vault and preserve privacy from the get-go, so to say.
Yes. Yeah. Yeah, and there's some interesting things that we're looking at as well. We have some internal demos built out where we can also use the Skyflow Vault in the policies and fine grained access control to control access ultimately to the files that are part of the training materials too, so that you can preserve potentially the policies that you might already have in place within your company based on how you have access to your Google Drive files set up, or your Microsoft files, or whatever that you're using internally for where you house your files, so that if you only allow certain types of employees to see certain types of files, we can also persist those policies through essentially the creation of the RAG model.
Awesome, thanks.
Yeah, and then I have we can so this is essentially the taking some of the sort of spirit of the original blog post that Ravi and Farouk wrote around essentially multi-tenant RAG
Mhm.
using EKS, and then showing where Skyflow would sort of fit into that picture. So we have sort of on the left here this isolated protected environment where that contains the sensitive data. So this is essentially restricted to the container around Skyflow, where this could be your data sources. We support a product called Pipelines, where we can securely connect to like an endpoint, like an S3 bucket or an SFTP server or something like that. Um, and have like a private public key encryption so that we make that as secure as possible. And then essentially Skyflow can, within its secure environment, detect and replace the sensitive data and drop that into, say, another S3 bucket, where essentially, in this case, the original training process that was in the blog post that you guys wrote picks up. And all that stuff sort of continues as normal. And feel free, Ravi or Farouk, to jump in and talk about some of the stuff here on the right in terms of the multi-tenant Bedrock deployment.
Yeah, Farouk, you want to give a quick overview, or Ravi?
Yeah, sure. So what happens is, in the original blog post, there is sort of a LangChain orchestration that basically is managing the prompts that are coming in from the user of the system, and then based on the prompt, it pulls in data from the vector database, and then it looks at additional data maybe from the buckets that belong to a particular tenant, and then it sends it to um, the containerized instances of agents that are actually talking to LLM. So taking the prompt and then sending it to LLM and getting the response back. So this is where nicely Skyflow can be integrated with that LangChain orchestration to redact PII data before actually sending it out to the LLM. So that fits in very nicely with that architecture.
Oh, fantastic.
Yeah, and I think one of the advantages you get with this approach too is that when if you're a global company trying to build deliver LLM technology to all your customers, and you need to comply with things like data residency requirements, so you need to keep your customer data essentially localized to certain regions. That's very hard if you're trying to run one global instance of your LLM application and pipeline, if it's touching the actual customer data. But in this situation, we can take essentially this left container and we can keep those things essentially deployed within specific regions. And then on the right, where we're aggregating the data into initially this S3 bucket, the head of this pipeline, that can be anywhere you want, because at this point it's essentially been descoped from the requirements of data residency, because it's not actually touching any raw PII. There's no PII on this side. It's essentially been either it's a combination of essentially the non-sensitive data as well as the non-sensitive de-identified data at that point.
To follow up on that, Sean, along with the data residency requirements or some of the regulations, also there's the whole right to be forgotten, also policies that come into play. So, how is that addressed by Skyflow, or is it?
Yeah, that's a great question. So one of the reasons right to be forgotten is so challenging for a lot of companies is because their customer data ends up all over the place. Like it's not like it's just in your database. It's in the backups of those systems. It's in your warehouse. You could have SaaS applications like a CRM, a marketing automation platform. All these things are essentially holding on to customer data. And by taking sort of this more this like shared service model to PII, similar to how you might use a shared service model for identity, what you're doing is all those systems essentially are just holding on to de-identified pointers that are references back to the original data. And the vault holds the mapping between that pointer and the original value. So when it comes time to do something like delete someone's information, as long as I'm deleting the information from the vault, essentially breaking that mapping, then all those de-identified values within your downstream services become meaningless. And I could, have, some sort of job that goes once in a while to go and clean those things. But for all intents and purposes, those systems now carry no relation to the original data.
That makes sense. So the system of record remains untouched, and you can deal with the right to be forgotten issues that come along with that, essentially separately from what's happening now inside of your actual LLM or fine-tuned model.
Exactly.
And because of that decoupling, then you don't need to worry about that. Yeah. So, sorry, go ahead, Joe.
Oh, no. Yeah, you're exactly right. So then this is sort of the inference model that we were talking about, where, and I'll give a demo of Verba GPT in a second, but the front end UI is built on Streamlit. We're taking a prompt, we're cleaning that through the gateway, creating the embeddings from the prompt, hitting the vector database to pull out the relevant chunks. And then one of the things that we did that's unique to the product that we were building was we're combining the chunks with essentially like what we call prompt template. And that allows us to generate responses that are formatted in such a way that's more useful to us. So they can be formatted like a blog post or formatted like a how-to guide in our documentation.
Mm-hmm.
And then we're using Bedrock to essentially perform the inference step. And then when the response comes back from Bedrock, we're passing that again through Skyflow Privacy Gateway to re-identify data as necessary and produce that contextual response.
Yeah, that makes sense.
All right, so when I think I have one more, and this is essentially what Farouk was talking about, where this is the inference process with Skyflow in the step. So this is essentially the same thing that I was showing here, but sort of mapped to the architecture that was talked about in the original Bedrock article using the EKS and multi-tenant approach.
Do have a question here as well, and I'm not sure if you're planning to cover this later, Sean, but I see here in the examples that you were talking about, you mentioned a container, right, around Skyflow. So is that the typical deployment model, or what does that normally look like for you?
Yeah, so that's a great question. So the Skyflow platform itself is containerized. That's how we are able to scale essentially depending on customer needs and the type of performance they need. But there's different deployment models for Skyflow. It is a managed service, so a lot of our customers, I'd say the majority of our customers, are under our multi-tenant deployment. So that's running within our AWS environment in a multi-tenant mode. We can also do single tenant deployment if you need that. And then there's also deployments where essentially we can run the control plane within our AWS account, and we deploy the data plane to your AWS account within a dedicated VPC, and then you have a secure link between the data plane and the control plane. And with all this, we have support. So that's kind of our bring your own cloud model, deployment model. But you can also bring your own encryption keys as well. So you're the only, even regardless of whether you're multi-tenant, single tenant, or the data plane's running in your environment, you're the only one that ever has access to that data. And if you need additional level of assurance and security around that, you can even bring your own encryption keys and be complete control of that.
Is the solution available on the AWS marketplace at this time, Sean?
Yes, absolutely it is.
Fantastic. So yeah, if you're out there interested in this, make sure and take a look on the marketplace to get started there. But sorry, I broke your train of thought. Please continue.
Oh, no worries. So I was just pointing out that this is kind of adapting that original paper to show where Skyflow fits into that. And again, it's really about trying to reduce the footprint of PII as much as possible across the various systems. Because most internal systems, whether we're talking about LLMs or we're talking about regular application infrastructure, they don't really need PII. They just need some sort of reference for it. Yet historically, we've built those systems. If you're building a microservice architecture or whatever, we built them in such a way that we're passing the sensitive data all over the place. And then that leads to this problem where we have essentially PII sprawl, which makes things like right to be forgotten or data subject requests really, really difficult. And then when it comes time for things like data security as a whole, it's very, very hard to make sure that all those systems are actually locked down and that we're controlling access in a consistent way, because we lose track of where that data is in the first place over time.
Right.
All right, so let's go and take a look at Verba GPT here. Oops. Make sure that things work here.
Live demos. We know how it goes.
There we go. All right. So
Nice.
I can chat with Verba. Like I can say, what is Skyflow? Sort of typical stuff that you would expect in any LLM interface. So this front end is Streamlit, and then essentially we're using Bedrock and so forth in the back end. So but one of the things, the real value besides Verba being trained on our internal information, so we get a much more relevant response. It can automatically link also to relevant docs because it actually has access to those types of things. Is when it comes to, we can draft content. And here, this is where we can attribute to this to different types of templates. So I could say I want to create a blog post, social media post, press release, or I could want to create docs. So I could say something like write documentation to guide how to integrate Skyflow with Stripe, for example. And maybe we'll take that and we'll also, just for comparison's sake, let's do, we'll go to ChatGPT and do the same thing. All right, well, that's still running. So the challenge, like ChatGPT is going to generate something, but the problem
It's only
here
what's available in its locus of context.
Yeah, exactly. So
it doesn't have all that custom information.
Yeah, absolutely. So it generates stuff, but a lot of it's just made up. Like, it's not, even the code that it's going to generate here is essentially, fictional code that it's making up. Like, this is not how, Skyflow's SDKs work and stuff like that. So maybe this is helpful from a starting point, but there's a lot of massaging that you would need to do in order to make this actually useful. And here with Verba GPT, we're getting the output that's, first of all, formatted in such a way that is aligned with how we produce documentation at Skyflow. And then also it's going to be able to automatically link to different other relevant pages, because it actually knows about those pages. And it can also generate code that is actually based on how our product actually works. So here it's connections is essentially our proxy product. So this is how you can use Skyflow Vault like a proxy to call a third-party API like a Stripe or Twilio or something like that, so that you're not handling the sensitive data. You're only ever handling essentially the tokenized data and so forth. And then it can link into these other things. So this is much closer to sort of final product than you would get with something like ChatGPT. So this has helped speed up significantly our ability to create docs, create content, and empower anyone within the company to be able to do this type of stuff as a starting point. And
it has the underlying PII protection as well that we've been talking about.
Yeah, exactly. And we're a data privacy and security company. Like, we might not be I could paste a lot of stuff into ChatGPT, but we might not be comfortable as a company sharing necessarily all that information. So I want to also take a look at, let's refresh this guy. Take a look at the actual detect APIs. So here, essentially, we're just hitting this endpoint detect text. There's a detect file as well if you're doing a file. And I'm passing in this case, like John lives in San Francisco. These are these allow sort of restrict lists I was talking about. And then we can also define which entities we want to be able to pick up. So if I run detect on John lives in San Francisco, just as a simple example here, I can see it's picking up John and name, because I'm allowing San Francisco. I didn't say anything about, location as part of the allow deny list. And this is essentially the response I'm getting directly from the detect endpoint. And then I can take a more complex example. Let's take something. I got a example here where I'm talking about, a 62-year-old female here for first visit. So this is basically like a doctor's note.
Makes sense.
And then if I run detect on that, again, I'm only picking out name information here, but I can adjust which entity types that I restrict on. So if we look at the actual documentation for the detect endpoint, there's all these different sort of, it's been trained to identify all these different types, and you're in control of which ones you want to detect and de-identify. So I saw stuff like, I think age was one in there. So we can go back and we can add age here. Oops, if I could type. And we can run detect there, and now I'm actually recognizing pulling out age. So
and it replaces with those I can see it over there under process text, name _1, age _1. Yep, in the text.
Yeah, and then it gives you essentially the indexing of that so that you can replace re-identify as necessary.
Oh, nice. Yeah, you've already done all the the thought process behind.
Yeah, so I'm trying to make it as easy as possible. And you can also, some of the things that we can give you confidence intervals on or sort of like the probability metrics of on how accurate we think it is, so that again, like if you, depending on what you're trying to do, if the probability is too low, maybe you just drop that. It's not high enough value to return to remove that while potentially degrading the performance of your AI model. So it's completely up to you. And then I'll do one other one here. So this is a lease agreement. a fake lease agreement, essentially. So I can take something like that. Obviously, ideally I would do it as a doc, but we'll just paste it in here for this as text. And then I can run detect on this, and we should get a whole bunch of different stuff. So we're going to get like dates and names all pulled out of this. And again, we can go and sort of adjust based on the various things. So we have like social security numbers, URLs could even be something that you need to pull out, IP addresses, vehicle IDs, all this type of stuff you're in control of. CVV, obviously, you'd probably not want to store. So there's a lot of stuff that it can automatically detect, and you can adjust like token formats here as well. I'm using essentially the unique counter in this case, but all this stuff's available to you. You can get adjust accuracy a lot, because a lot of this comes down to, like we've talked about, being able to make adjustments depending on what you're trying to accomplish. So we're trying to give as much flexibility around this as possible for people so that they can really limit the risk that they take on in terms of PII or other sensitive data exposure, while still trying to derive as much value as they can get from the product that they're building. And this is the file endpoint. So here we support these various files today. I know you asked, including images.
Oh, those are all the different types there. Oh, nice. Yeah. Okay.
So
Sean, I've got to say, unfortunately, we're actually coming up on time here. Was there another quick question though?
I did have a quick question on Verba GPT. It's really great to see that that you're using that internally. So I wanted to really quickly talk about the level of confidence that you have in the content being generated, and also talking from a hallucination perspective, and again the data quality perspective of the content that is being generated. So if you could speak to that for a minute, I think that'll be great.
In context of Verba GPT?
Yes, the content that it's generating, and the level of confidence you have in that, especially the URL links that it's generating, and some of the reference to stuff that it's generating, in it being real and not being kind of fakely generated.
Yeah. I mean, I think that's why RAG is so popular. It is a way to reduce hallucinations. It's also a way to have more real-time information as well, because generally a foundation model is fixed in time at a certain epoch. So it could be 2 years out of date, and it doesn't know, you're a new company and it doesn't know anything about you, for example. So that's not tremendously valuable, but you can augment that by adding additional context through RAG, which is super, super valuable. And then it's like any system, is especially when we're talking about AI, it's not going to be 100% bulletproof, but it's much, much closer to being sort of final product, where I would say the majority of the links that we're producing in Verba GPT are accurate. They do actually go to a page. Now, luckily, we're talking about generating things like blog and how-to guides and stuff like that. It's not necessarily, it's super valuable to us, but it's not like we're trying to predict someone's whether they should see a doctor or something like that. So I think that also is something you have to take into account. If you're building, like our customer, a digital nurse, the bar for accuracy and your tolerance for something like hallucinations is very different than, hey, I need to help me write a social media post. So those are things that you have to take into account when you're building any type of system like this.
Thank you.
Thanks so much. Thank you, Sean, so much for being here and really sharing with our audience this great information about Skyflow. I think it's a fantastic tool. If our audience wants to find you, I see Bill put skyflow.com into the chat here, but if they're looking to see you or find more information, Sean, where should our audience go, or how should they look for you?
Yeah, absolutely. I mean, skyflow.com is a good starting point. You can also find me on LinkedIn, is probably where I'm most active. If you look up my name, there's not too many other Sean Faulkner spelled exactly like me, although there is another Canadian Sean Faulkner that works for AWS. So don't get confused, although he might be happy if you reach out as well. So you'll find me out there if you do a little bit of searching. It's not too difficult.
Awesome. Thank you so much again, Sean. And Ravi and Farouk, thank you both as well. Always wonderful to have you on the show. Look forward to having you back again in the near future. And to that, also to the audience, this is the end of our season 6 of the show. We will be on a hiatus for about a month. We will be back later on in July. So look for our announcements on LinkedIn for our next show. But other than that, until we speak again, Happy building, everyone. And thank you very much for being here with us.